Hello, everyone. Today we are going to talk about properties of logarithms. Before we go on with our lesson, let's do few problems based on our last activity. We call it do now activity. Use the approximation log of 2 is approximately 0.3010 to approximate the values of each of the following logarithmic expressions. So we need to find out log of 20, log of zero point 0.2, and log of 2 exponent 4. Let's start with the first one. So as I told earlier, we can rewrite log of 20 as the product of 2 and 10. So 2 times 10 is 20. Then we can write this as log of 2 plus log of 10. Now log of 2 we already know is 0.3010. So we just write its value 0.3010 and log of 10 is 1. So our answer will be 1.3010. Now if you do the same problem, but this time instead of 20 we have 0.2, we can write this as log of 2 times 10 exponent negative 1. So that will be log of 2, which is 0.3010, and log of 10 exponent minus 1 is negative 1. So when you subtract as then your answer will be 0.70 approximately. Okay. Now the third one, again, it would change to, now we'll use a different property. So this 4 will come out and we will have log of 2. So then 4 will be multiplied with the log of 2, 0.3010, and then we will have an answer of 1.2040. Okay, so this is how you solve these problems. You basically, if you have a number, you try to break it up, split it so that you can have smaller numbers, and then you can simply find the value of log of 2, and then whatever you have is in terms of an exponent for 10, and that can be simplified easily. Okay. So now moving on, talking about key points. So we know that logarithms and exponents are inverses. So if we have an exponential expression x is equal to b exponent L, that means L is the logarithm for base b or of some uh, x. Okay, so x will be when you have a base b and L is the exponent in the exponential expression and L is the logarithm in case of a logarithmic expression. So these two expressions, log of base b of x is L and x is equal to base b exponent L. These are the two expressions. The first one, this is a logarithmic expression, this is the exponential expression, and they are inverse of each other. The second point is logarithmic properties rely on exponent laws. So all the laws that we learned which apply to exponential expressions apply to logarithms as well. Some key properties are listed here. Log of 1 is 0, log of 10 is 1, log of 10 exponent k is equal to k. So it should be not 10, it should be 10 exponent k. Okay, I'm sorry I couldn't make it an exponent, but when you have the log and then the 10 base for an exponent, they cancel each other out. 10 log of x, sorry, again, it should be 10 exponent log of x is equal to x. Again, the exponent and the log cancel each other out. If you have to find the log of product of two terms, x and y, then it's the same as log of x plus log of y. If you have log x times k, then k it should be x power k. So log of x with exponent k, then you will have k times log of x. Okay, so Then log of 1 upon x is negative log of x. Log of x upon y is equal to log of x negative log of y. So all these properties are very important, and we will make use of these properties while solving the logarithmic equations. To solve an equation involving exponents, you can apply a logarithm to both sides of the equation as long as you don't take the logarithm of a negative number or zero. So we have been studying polynomial expressions or some other equations, and we take the square root of on both sides, or we divide by a number on both sides, or we add or subtract something on both sides. The same way, we can take the logarithm of the expressions on both sides of the equation. All we need to do is to make sure there is not a negative number or there is no zero, because we cannot determine the logarithm value of a zero or a negative number. Okay, so now with key points discussed already, let's look at these properties yet again as part of the teacher model. So properties of base 10 logarithms. Here it's the same stuff except that we don't have those mistakes for exponents. Log of 1 is 0. Log of x means 10 base L, 10 base with an exponent L is going to be x. So basically here we have 10, but it doesn't show because it's a common logarithm. This 10 moves to the other side, so it shows up like this. And if we have L on the other side, like we have here, then L goes to as a power, or then x or as an exponent. So that is equal to this x. When x is equal to 1 and L is equal to 0, so any base, if we have base of 10, if it has an exponent of 0, then it is equal to 1. So this is the justification why log of 1 is equal to 0. Again, log of 10 is equal to 1 because 10 with an exponent of 1 is 10. Okay. For all real numbers r, log of 10 exponent r is equal to r. Now here again, if you have an exponent r, then exponent 10 exponent of r is going to be 10 exponent r. So this is the third property. For any x which is positive, that means greater than 0, 10 exponent log of x is equal to x. So because L is equal to log of x means 10 exponent L is equal to x, then x is equal to 10 log of x. So we need to make sure we are very well familiar with these properties, and then we will use this. So property 5 says log of x multiplied with y is equal to log of x plus log of y. We have the same rule in case of exponents. A base with an exponent b and a base with an exponent c, when multiplied together, the exponents are added. So similarly, if we have the logs added together, that means they can be multiplied. And then property number, this is just an explanation how this can be equal to, but in all the cases, property is what you must keep in mind. The rest is basically the justification. Then property 6 is for any positive real number x and any real number r, log x with an exponent r is equal to r log of x. So any exponent which is within the term involving a log, that comes outside and multiplies with the log of that. So if you want to solve a problem involving exponents, you can apply a logarithm on both sides of the equation. Just make sure that there is no zero or there is no negative numbers. Okay. So if, for example, if we have an expression x is equal to y, we can also write this as log of x is equal to log of y. Okay. So with this, let's do the first example. Apply properties of logarithms to rewrite the following expressions as a single logarithm or number. So the first part says 1 upon 2 log of 25 plus log of 4. We need to combine them. So first of all, this thing I can rewrite as log of 25 power 1 over 2, and then I can just write this as log of 4. Okay. Now, what is 25 square root? It's 5 times 5. So I can write again is as log of 5 plus log of 4. Okay. So in this case, I use the property that log of x with an exponent of r is equal to r log of x. So I first use that, and then here in this case I simply multiply 5 and 4. So I would, my pen is giving away. Okay, just a minute, let me bring another pen. Okay, I'll just work with the pencil. So log of 5 times 4. So here we are using the property that log of x multiplied with y is the same as log of x plus log of y. So we go from the right hand side to the left hand side. So we multiply 5 and 4 and we end up with log of 20. So this is our final answer. We have been able to combine all the terms and write them as a single logarithm or number. And log of 20 you can further evaluate. We already did that as part of the do now activity. Now the same way we do the second problem, 3 log of 5 is the same as log of 5 exponent 3, and then we have log of 0.8. Then 5 of 3 is 125, so we write this as log of 125, and we multiply it with 0.8. So 0. Now this I just write as multiply. So when you multiply these together, then you will get log of 125 times 8 is basically 1000, and you have a fraction, so it ends up as like this. Okay, so 540, 1620, yeah. So now log of 1000 is the same as log base 10, 10 exponent 3. So the log and the base of this exponential term, they cancel out, and you end up as your final answer, which is 3. So here it is the same as, you can say, log. Let me show you the same identity we had before. 10 log of x times r is x times r. So or 10 log of x is equal to x. Okay, so 10 log of x is equal to x. We are using this property, and this is our final answer. Okay. So in all these three problems, we had uh, multiple terms involving logarithms, and then we used the properties of logs to combine them and come up with a single logarithm or a value. Okay, so these two problems we solved that way. Now we are going to do the opposite. Rewrite each expression as the sum of terms involving numbers log of x and log of y by applying properties of logarithms. So now we do the opposite. Now here, first of all, I see all these terms together and then a logarithm for these. So I'm simply writing them separately as log of 3 plus log of x squared plus log of y power 5. Okay. Once I do that, then I can go ahead and further write it down as log of 3. Now this log of x squared is the same as 2 times log of x, and then log of y power 5 is the same as 5 times log of y. So this is how I break down the log term. So I Again, use the same property, log of x times y is equal to log of x plus log of y. Okay. Now let's do the second part. Log of x power 7 y cubed. We write this as log of x power 7 y cubed power 1 over 2. So square root we change to the power of 1 over 2. Then we write this as log of x power 7 over 2 y power 3 over 2. So you can see that the powers basically multiply in this particular case, and you have the same base but you have two powers on top. Now in the first case we write this as log of x power 7 over 2, and then we write plus log of y power 3 over 2. So xy we separated. Then we take the powers outside. So we can write this as 7 over 2 log of x plus 3 over 2 log of y. So now you can see that I was able to separate these, and exponents came outside, and I took the products out as log of each. Okay. So remember, first step, you had the square root. You change that to power 1 over 2. Second step, you multiply this exponent with each of the exponents inside. So 7 times 1 over 2 is 7 upon 2. Y exponent 3 times 1 over 2 is y exponent 3 upon 2. Then you separated these two terms. Log of x, exponent 7 upon 2, plus log of y, exponent 3 upon 2. And in the final step, you took the exponents outside, so you ended up with 7 upon 2 log of x plus 3 upon 2 log of y. Okay, so these are the steps you take to solve your problem. Now let's do example number 3. If x is equal to y, then log of x is equal to log of y. Use this property to solve these. So let's do the first problem. We have 10 exponent 10x is equal to 100. Let's write this as 10 exponent 10x, and 100 is simply 10 squared. Okay, so now we have two expressions, and if we take log on both sides, we will have log of 10 exponent 10x is equal to log of 10 squared. So now the log and the base 10 for the exponential expression cancel each other out. So I will get 10x, and similarly log and base 10 for the exponential expression will cancel out. I'll get 2. Now all I need to do is divide both sides with 10 so that I can get rid of this 10 next to x. So I will have x is equal to 1 over 5, or I can also write this as 0.2. Now to check out if you did it correctly or not, all you need to do is input this value into your original function. So 10 times 0.2 is 2. So that's the same. Your answer is correct. Now, part B, it's a bit tricky, but we just take one step at a time and we know how to solve it. So we have 10 exponent x negative 1, and we have 1 upon 10 exponent x positive 1. So first of all, we must bring this thing up. So if we do that, this side remains as it is. And in this case, remember, whenever you bring a term with an exponent up or down, the sign of the exponents change. So plus x plus 1 will change to negative x negative 1. Then you take log on both sides. So you will have log of 10 exponent x negative 1 is equal to log of 10 exponent negative x negative 1. So now again, log and the base 10 cancel each other out. So you will have x negative 1 is equal to negative x negative 1. You try to get rid of this x from here, so you add x on both sides, and you get rid of 1 from here, so you add 1 both sides. So these x cancel out, these ones cancel out, and even these ones cancel out. So x is equal to 0. So this is the final answer. Now if you want to check, 0 negative 1 is negative 1, 10 exponent negative 1 is 1 upon 10. 0 plus 1 is 1, 10 exponent 1 is 1, so it is already 1 upon 10. So our answer is correct. Okay. So what did we do in this problem? First step, we took this term up. When we took it up, the exponent signs changed. Second, now that we have the same base 10, we can, as long as we have the exponential expressions on both sides, even if it's not the same base, we can still take the log. We'll see if we can have more problems on these lines. So we took the logarithm on both sides. We have x negative 1 equals negative x negative 1, and then we just solve for x, so we get a value of 0. Now we'll do the third part of example 3. 10 exponent 2x is equal to 10 exponent 3x negative 1. Sorry, here we have 100. So 100, if we need to change to, obviously 100 is 10 squared. So I will write this as 10 squared, and then I have the exponent 2x. And here I have 10 exponent 3x negative 1. Okay. Now these exponents will multiply. So I will have 10 exponent 4x is equal to 10 exponent 3x negative 1. Then I take the logarithm on both sides. So log of 10 exponent 4x is equal to log of 10 exponent 3x negative 1. The logs and the base 10 will cancel out. So I will have 4x equals 3x negative 1. I subtract 3x from both sides because I'm solving for x. So I end up with x equals negative 1. So this is my answer. Now, if I want to check, 100 exponent 2 times negative 1 is equal to 10 exponent 3 times negative 1 negative 2. So this is 100 exponent negative 2. Sorry. That is 1 upon 10,000. And here 10 exponent negative 3 negative 2 is negative 5. 3 times negative 3 negative 1, sorry, it was negative 1 here. So negative 3 times negative 3 negative 1 is negative 4. So it is 1 upon 10,000. So you can see that I can always check if I did my answer correctly or not. So this is to confirm. So always make it a habit to check if you got the right answer or not. Okay, so now we do the example 4. By the way, I'll just leave it like this so that you can have a look and make a note in your copy as well. Now let's do this problem A for example 4. Solve the following equations. Like I said, we can have different base. Still we have the exponential terms. So 10 exponent x is equal to 2 exponent 7. If we take the log on both sides, log of 10 exponent x is equal to log of 2 exponent 7. Then we will have x is equal to 7 log of 2. Because here this is a common log, this is log base 10. This directly does not cancel, only these cancel out. So x is going to be 7 log of 2. Okay, and somehow if you know the value of log 2, we remember it was 0.3010, so we just multiply 7 with 0.3010. So it's going to be 0702.1. So this is our x. If you don't do it, you just stop here. That is good enough. Now here, 10 exponent x squared plus 1 is equal to 15. And how to solve it? 10 exponent x squared plus 1. So what we are going to do is we're going to take the log. So we will have log of 10 exponent x squared plus 1. And here we're going to have log of 15. Okay. Then in the next step, this log and this 10 base cancel each other out. So we end up with x squared plus 1. And that is equal to log of 15. So at this point, you can go on and solve for x. You can just find the value of log of 15. So what we do is we just subtract 1 on both sides. So we will have x squared is equal to log of 15 negative 1. And then we just take the square root on both sides. So our x will be equal to plus and minus log of 15 negative 1 square root. So you can see that you don't have to think about the final answer, just one step at a time. Here you took the log 15. We don't know what's going to happen to 15. So just let's leave it like this. But when we take the log, this is log 15. Log and this 10 base cancel each other. So we have x squared plus 1. We solve it for x. So we end up with this answer. So now if someone wants to calculate the value of log of 15 and then come up with an answer, good enough. Otherwise, this is also good. Last problem. 4 exponent x is equal to 5 exponent 3. Okay. So obviously take the log. So log of 4 exponent x is equal to log of 5 exponent 3. So it's going to be x log of 4, and it's going to be 3 log of 5. Okay. Now you need to get rid of log of 4 from both sides. So you divide both sides with log of 4. So that you get x is equal to 3 log of 5 divided by log of 4. And then if you want to go ahead and come up with a numerical value, you can simply take the log of 5 and log of 4, and then you can solve it. But as long as you solve this far, you're good. So again, you had different bases. You had base 4 and base 5. You had different exponents. You took the log on both sides. X comes outside, you have log of 4. 3 comes outside, you have 3 log of 5. And then you divide both sides with log of 4 because you want to find what x is. So when you do that, x turns out to be 3 times log of 5 divided by log of 4. So this is your final answer, and this is how you do it. So in the end, to conclude, I will again go back to the 6 properties. These I would like you to keep in mind. Log of 1 is equal to 0. Okay, so this is the first property. If you think in terms of exponents, 10 with an exponent of 0 is 1. The second property is log of 10 is equal to 1. So I'm again putting this in a box. So here 10 exponent 1 is equal to 10. So this one comes here, this 10 comes here, and this is, this 10 comes here, and this is the 10 for base of 10. Okay, third, log of 10 exponent r is equal to r. So now when you have log and an exponent expression, so the base and the log, they cancel out, you end up with r only. Next property is property number 4. So if you have 10 base and you have exponent log of x, again the base, the exponential base and the log cancel out and you get x. So these two things are pretty much the same, except that here you have log outside and exponential expression inside. Here you have exponential expression with x power or exponent as the log. So this you should look very closely and try to remember this. This property is, we have used it very extensively recently. So log of xy is the same as log of x plus log of y. That we should keep in mind. And then the last property is property 6. Log of x exponent r is the same as, you take r outside, r times log of x. So these are the properties. And the final thing, which is also very important, is that you can take the log on both sides, provided a big condition, x and y are both positive. No negative number and no 0. Okay, so these two conditions have to be met and you can take log on both sides. So with this, I will stop this lecture here. Make sure you do all the practice and then you do independent practice problems, which are basically following this teacher model. So just to give you an idea, this is the independent practice. You are given the values for log of 2, log of 3, log of 5, and log of 7. So you will change these numbers for which you are supposed to find the log into a product of these numbers. 6 you can write as 2 times 3. Then you will find out log of 2 plus log of 3, and you will solve it. So you'll do this, all these problems the same way. And second, here you will combine your terms to get a single logarithm or number. And then in the end, you will do these problems. These are a bit, I have listed all the properties here. You can make use of any of these properties and then you can combine this to write a single logarithmic expression. And then the last one is the opposite to problem 3. You have a huge big term and you need to split it, so you can write it in terms of log x, log y, log of z, and numbers. So these are the practice problems which I want you to do, and then you will have developed mastery in this subject. Thank you so much. See you next time. Bye.